Hey everybody, this is Tom, aka Lightning Boy, and welcome to the Lightning Boy Racing Workshop. In this video, I'm going to explain to you the process I use to verify the alignment after I drill the axle holes in a block. Now, I firmly believe that alignment is the foundation to speed, so I've spent quite a bit of time thinking about and perfecting this particular process. Now, one of the nice things about alignment, though, that unlike some of the other Pinewood Derby speed elements, alignment is actually something that you can isolate and measure. And what's also nice about this is that once you have perfect alignment, once you know you have perfect alignment, you can't get any better than perfect alignment. So once you know you have perfect alignment, you can focus on other aspects of the build. You can focus on your prep. You can focus on maybe your aerodynamics. You can focus on maybe a new wheel cut. But you can focus on all those things knowing that your alignment is perfect and can't get any better. Now, one of the things that actually drove me towards creating this process was the X3 design. So here's the X3 design, the car that started it all, and you can see that the fenders here are pretty elaborate, and they take quite a bit of time to build. And you can probably imagine the disappointment after you put all the time and effort into building these fenders to have the car not perform just because it has bad alignment. Now, personally, I don't have to imagine that because it's happened to me, and let me tell you, it's not fun. So to avoid that, I wanted to create a process where I knew without a shadow of a doubt that the alignment was spot on. And that kind of leads me to really the core reason why I developed this, and that is the inherent weaknesses of the current popular alignment tests. So let me explain that. So the most common alignment test that you'll see out there is the roll test. And the roll test is simple, it's fast, and it's a good approximation, but that's all it is a good approximation. What I mean by that is the way the roll test works is that it depends on this 3-degree cant on the axle, forcing the wheel to migrate away from the body. And the idea of the roll test is that if this axle has some toe-in, the toe-in is going to force the wheel to migrate in towards the body. And so if you roll if you roll the car down the board and you don't see the wheels pop out and migrate away from the body, then you have some toe-in and you have a bad drill. Well, that works as long as you have enough toe-in. If you just have a slight amount of toe-in, however, what can happen is that this 3-degree angle, the force imparted by this 3-degree angle, actually overcomes the slight toe-in, slight migration in force imparted by the toe-in. And in that case, the wheels will still migrate out, and you'll think that you have a good drill when in fact you don't. So some of you might have seen a video I posted a while back which describes a modified roll test. Let's call it the controlled roll test. And in that test, what you do is you control the car more by pushing it down or pulling it back up, and also you swap out the axles for these pin gauges. Now, that particular test is a better approximation, but it's still just an approximation. So in that scenario where you have just a slight amount of toe-in, the controlled roll test might expose that, and it will expose it by the fact that the wheel with the toe-in will migrate just a little bit slower than the other wheel, without the toe-in. But that can be hard to detect, and not only can it be hard to detect, even if you do detect it, it could be explained by other factors, such as maybe the wheel bore is shaped differently in that particular wheel. Another issue, and this applies actually to both of those tests, is that those tests don't actually test other aspects of a good drill. So they check the alignment, but a good drill has other aspects. So there's the location of the holes, there's the angle that the holes are drilled at, and there's the height of the holes. So the quality check I'm about to show you actually involves 4 different validations, which I refer to as a 4-point quality check. So quality check number 1 validates the alignment of the holes. Quality check number 2 validates the location of the holes. Quality check number 3 validates the angle of the cant. And quality check number 4 validates the height of the holes. So we're going to get started. The first thing we're going to do, though, is we're going to talk about the different tools you need to perform this process. All right, first let's walk through the various tools I use to do this 4-point drill quality check. Going from left to right, over here on the left I have a couple of different combo squares. I also have this nice little machinist square, which is extremely handy for a lot of different Pinewood Derby tasks. And also I have the silver bullet. Now, the silver bullet itself isn't necessary to do the drill. I actually happen to drill the holes with the silver bullet, but you could drill the holes with the goat boy tool or whatever technique you want. However, this particular technique for doing the quality check does rely heavily on the silver bullet, so it's a critical tool in this process. Of course, we have some pin gauges. I have pin gauges of various sizes. What I'm using here are a couple of 90 pin gauges because the drill bit I use to drill the hole is a 43, so the 90s fit nicely into those holes. I also have these solid 3-2-1 blocks. Now, the solid 3-2-1 blocks aren't as common. Aren't as common as the 3-2-1 blocks with the holes. So if this is all you have on hand, these will work. However, later we'll be doing a visual validation using light, and these holes let too much light through to make that validation easy. The solid blocks then work a lot better for that visual validation. And finally, what we have here is just a simple metal protractor that I just picked up at any hardware store. All right, so the first of the 4 quality checks that I'm going to perform is also the most important one, and that is the alignment check. Or in other words, are the 2 holes drilled such that they are straight to one another, relatively straight to each other? Now, one of the key concepts that I'm using here is the fact that my drill table is set up to be perfectly square to my drill bit. Now, because of that fact, what I can do is to do this check is I can check to make sure each side is square to the silver bullet. Now, there are many folks who don't have a completely square drill table, at least square to their drill bit, and you can mitigate that by flipping the block in such a way that it mitigates the error. And I'll talk about that situation in a bit, but for now, let's assume that we have a drill table which is square to the drill bit, and therefore to check the squareness of the drill, I just need to check to make sure it's square to the silver bullet. So what I do is I take my solid 3-2-1 block, and basically you're going to hold it up or push it up against the pin, and then check for the squareness there. But there's a couple gotchas here. First is that the drill is actually drilled at a 3-degree angle in the vertical plane. So what that means is that if I push this up, but if I angle the block a little bit, that's actually going to mix the vertical and the horizontal planes and give us a bad result. So what I need to do is make sure that this is straight in the horizontal plane. in order to do that, what I use is this small machinist square. I put that up on the silver bullet like so, so it will slide up and down. And then I put the 3-2-1 block up against that, and then simply slide the whole thing up to touch the pin. Very slowly, just so it just touches. So that way I know that the 3-2-1 block is completely straight in this vertical plane. And now I'm checking just the squareness of the horizontal plane. Now I'm going to be getting down low here and checking for gaps then in between the pin and the 3-2-1 block. In this situation, light is your friend. So what I like to do is I like to hold up like a white background, and then just scoot down here and then look for any gaps between the pin and the 3-2-1 block. So what you're seeing now is a close-up of the pin up against the 3-2-1 block. And if you look extremely closely, you should see a little bit of light leaking through at the bottom. So what that's indicating is that this drill is actually off. There's a little bit of toe-in on this drill. And it's just a very minute amount. You can just barely see it at the bottom. One thing you need to be careful about, especially with toe-in, is that you don't push the block too hard up against the pin, because if you do, I don't know if this will come through, but if I just push that a little bit more, a little bit harder, you should see that the gap completely closes. So you want to just push it right up to the point where it makes first contact with the pin. Okay, so now I put a pin in the hole on the other side to test this one out. And I'll just do the same exact thing. I have the 3-2-1 block, the square to run this right up against the pin. So if you look at this one, you won't see any gap whatsoever, which means that this is a good drill. Alright, so the upshot then is I have one side which is drilled a little bit off and the other side is drilled perfectly. And that's actually exactly what I expected with this particular block, because I actually set it up to work that way. What my drill table is actually a little bit off. And so what I do is I shim it with this very small feeler gauge here. It is 6/1000 of an inch thick. And so all I did for the one that was drilled incorrectly was I took away the shim. And you can see that that small little difference actually turned up quite obviously in the alignment check. So that's point one, the actual alignment. Are these two drills completely aligned with one another? The other quality check I do is the location check, and that's to make sure that the two axles are drilled directly across from one another. In order to do this check, what I do is, again, I use my 3-2-1 blocks, and I push them right up against the pins again. I take another square and I run that square up against the 3-2-1 blocks. Now, in theory, if my holes are directly across from one another, neither one of these should move now. But what actually happens with this one is this one moves. You can hear it clicking. It moves, and if I look closely, there's probably about a 32nd of an inch gap there. And what that tells me is that this hole is actually drilled a little bit farther forward than this hole. So again, something that I did intentionally to demonstrate this. Okay, so I've checked the alignment and then I've checked the location. The third quality check I'm going to make is to validate that the vertical angle on the drill is 3 degrees. Now, this is not one I obsess over. I'm actually not that worried about the fact that the angle is exactly 3 degrees. What I'm more interested in is whether the angle is the same on both sides. So what I do in this case is I take my metal protractor, and in this case I've actually already have set it at 3 degrees, and then I could just simply hold it up against the pin here and then square that up as best I can, and look to make sure that angle is about 3 degrees. Now if I see some gaps here, then it probably means that my angle isn't 3 degrees. In that case, what I would do is I would loosen this up and reset the angle. So I would set the angle to whatever it is here on this side and then validate that it's the same on the other side. Now in this case, however, it looks perfect at 3 degrees, so that looks good. All I need to do is then flip it over, take it to check the other side. Same exact process, just hold that up against the pin, make sure there's no gaps, make sure that it's about 3 degrees. In this case it is, so for this quality check, this particular drill passes. So for the fourth and final quality check, what I want to do is verify that the two holes are drilled at exactly the same height. Now relative to the other quality checks, this is probably the least important, but one that I still like to do. All I do in this case is take a typical combo square, loosen it up here, then holding that right up to the bottom of the pin, and then square that up to the bottom of the block. Make sure that's nice and tight and square, and then lock it in. So now I have the height set on that side, and then all I need to do is flip it over to the other side and confirm it's about the same. And here it is. It's right up against the pin, and it's squared up against the bottom of the block, so therefore the height here is perfect. Now let's talk about the scenario where your drill press is not perfectly square to your drill bit, and therefore what you do is you flip the silver bullet when you are drilling in such a way that the error on one side is mitigated by the error on the other side. Now, how that would manifest itself in the check that I just displayed is that one side will have a maybe a slight toe in, where the other side will have an equal amount of toe out if you're checking it against the squareness against the silver bullet. So if you think that's the case, there is a way that you can still perform this validation with the silver bullet, but what you need to do is actually take the block out. So I'm going to slide the block out. I flipped the silver bullet upside down. I just put the block on right on top of the silver bullet, and now put the two 3-2-1 blocks together. Now, then what I'm looking to do here is get one of these pins flat up against the 3-2-1 block, and then move the other one up to touch the other side, the other 3-2-1 block up to touch the other pin. So what's going to happen then is if your if the drill is straight to each other, then you should be able to find a place where both of these pins are aligned perfectly with these blocks. It'll mean the blocks will have to move up a little bit or back a little bit relative to each other, but you'll be able to find a place where they line up. However, what'll happen in this case, because one side is a good drill and the other side is a bad drill, or is that if I line up one side, the other side is going to show either toe in or toe out. But that's what you can do if you have a table that is not quite square to your bit, and you expect, a little bit of error, but the opposite error on either side of the drill. Okay, so I'm back at the tuning board, and I thought I'd show you what I meant earlier about the roll test being a good approximation. So I'm actually going to perform a controlled roll test using the block that we've been working with here. And we know from the earlier validations that this block has some problems. Number one, the one side is drilled with a little bit of toe in, and the other side actually has a good drill, but it's drilled a little bit farther forward than the other. So I just wanted to show how this block performs under the controlled roll test. So I'll just, as always, just roll this down, and then as I'm rolling, again, what we're looking for here, we're looking at how the wheels are migrating. Now, if we look closely here and here, pretty much the same. Very hard to see any real difference there between the gaps. And as I roll it back, again, looking at those gaps there and there, again, yeah, really hard to see any real difference. And backed up pretty straight, almost exactly on the line. There's just a little bit, it's just a little bit off from where it started, which was straight with that line there that you see, but hardly anything that would really cause any alarm. So with this controlled roll test, which is even more sensitive than the roll test, we still don't see the toe in that is in that drill, and of course we're never going to see the fact that the one side is drilled a little bit farther forward than the other side. Well, I just have one more thing I want to show you guys, and that is that as I perform this 4-point quality check, one thing I do is I write the results right down on the block itself. I have a rating system from 1 to 5, where 5 is perfect, and I just write that down. Hopefully that you can see that there. This particular one is 5s across the board, so all 4 quality checks passed with flying colors. And this is a block that I would use to build a car out of. That does beg the question, though, what on earth am I going to do with this block? This is the one that I used in the video, and showed that we actually have some issues with this block. Toe-in issue, and one of the hole is drilled too far forward. Some guys just toss blocks like these. Other guys will destroy it in some satisfying way. I think what I'm going to do is I'm going to mail this to my friend Hurricane. Pop that right here in this envelope. I've got a letter here written to him. Dear Hurricane, I drilled this block just for you. Hope you like it. Sincerely, Lightning Boy. So I'll mail this out to him. Sad thing is that he'll probably still build a car that'll beat mine. Just the way it goes. So I hope you like this video. I'm really excited that I'm seeing a lot of racers tackle this X3 design. I know it's a complex design, and I'm hopeful that this alignment process that I'm showing you will give even more racers the confidence to tackle that design. So good luck, and thanks for watching.